Hi everyone, this is the fourth video for section 2.1 on sets. So we're just going to keep going through and doing some more examples. So now we're going to talk about a little bit different examples of using concerning subsets. So example 4 says, how many subsets does the set the set containing EAT have? So first off, I think it's easy to start out with finding the cardinality of the set. So the cardinality of the set is of the set containing E, A, and T is 3. Just because there are 3 elements in this set. So that means that we can have subsets containing a different number of elements. So we can have 0 elements, 1 element, 2 elements, and 3 elements. So we can have subsets containing 0, 1, 2, and 3 elements. Right? Because a subset just has to have, well, it has to have less elements, right? Because anything in a subset of any element in a subset of the set containing E, A, and T has to have the same elements. Let me rephrase that. So if we have X is a subset of this set EAT, and then everything in X has to be in Y, has to be in the set EAT, so it has to have 0, 1, 2, or 3 elements. So first off, the set containing 0 elements is unique, right? There's only one of them. So the first subset that we can look at is the empty set, right? The set containing 0 elements. So next we'll consider subsets containing 1 element. So we can have the set containing E, the set containing A, the set containing T, right? Those are our what these are typically called singleton sets, but the sets containing 1 element. And now we'll look at subsets containing 2 elements. So we can have E and A. We can have E and T. And we can have A and T, right? And remember that the order of a set doesn't matter. So the set EA is the same as the set AE. We just need to leave out one of the 3 elements to have a set with 2 elements. And lastly, we have the set containing all 3 elements, right? E, A, and T. So this one is the subset that's not proper, is this one that has all 3 elements. It's the exact same as the set. So these are the subsets. And we have 1, 2, 3, 4, 5, 6, 7, 8 total subsets. So yeah, just remember that if you have a set with some size, some cardinality, then any subset will have less than or equal to that same cardinality. And the smallest cardinality any set can have is 0. Right, you can't have negative elements in a set. That doesn't make any sense. But the smallest cardinality that you can have is 0, namely the empty set. And then you can just increase up to the size of the set you're looking at. Okay, so example 5, we have E being a subset of F and F being a subset of G. And we want to discuss whether E is a subset of G. So think about this. So there's more than one way to do it, but I encourage you to pause the video and think about if you think that this is true. So one way that we can solve this problem is using a picture. Remember the 4 steps to problem solving? So once you understand what the question is, we make a plan. And so the plan that I want to use is drawing a picture. So we know that we can represent something being a subset of something else by drawing these pictures. If we have this set E and the set F, E being a subset of F means it's contained in there. But we also know that F is contained in a set G. So E is contained in F, and F is contained in G. So that means that, right, clearly by this picture, yes, E is a subset of G, right? We can see that based off of this picture that we drew. So another way to do it, if you don't want to think about it in pictures, you just want to do it straight off the definition. So because E is a subset of F, means that every element of E is in F, right? And F being a subset of G means that every element in F is in G. So that means if every element in E is in F and every element in F is in G, well, that means that E is an element of G. So whenever you're writing this out for your homework or in the exam, write out all of these words I just said. So I'm not going to write them here because you're listening to them or reading them off of captions. So yeah, write out this full answer. But this is an example of what is called the transitive property. So the transitive property. So this is a property that different relations can have. So this one being a subset of something, that relation has this transitive property. And so different relations have different properties. Yeah, and we'll look a little bit more at this later, but this is just an example. Not everything has the transitive property, but it's just, you can transition that property between, that relation between E and F, we can transfer it. We can take the relation between E and F and the relation between F and G and transfer it, transition it into this relationship between E and G. So yes, this is true. Okay, example 6. So we have X being a subset of Y, and we want to know a lot of things. So the first thing we want to know is the minimum number of elements in the set X. So we know that X is a subset of Y. So what is the smallest number of elements that a subset can have? Well, we know that based off the note above, that, so we know that the empty set is a subset of all sets, right? So we know that the empty set is always a subset of any set that we're given. So the empty set has 0 elements. So the minimum number of elements in X is 0, because the empty set is a subset of every set. But we also listed it right up here in example 4, that the smallest, right, subsets can have 0 up to the cardinality of the set elements. Okay, so the next question is, can Y be the null set? So if Y is the null set, then we want to know, can X be a subset of the null set? So what we talked about up there in example 4, so since we're considering Y as the null set, that every subset has to have 0 up to the cardinality of that set elements. So because Y, this null set, has 0 elements, that means that X would have to have 0 elements. And so we know that, yes, if X is the empty set, then X is a subset of Y. And this is because, right, so this is where that notation matters, that this has the subset with the equal sign under it. Because in this case, X is a subset of Y is just saying that the empty set is a subset of itself. And in that case, X and Y are equal. So if this question said something a little bit different, if it instead said X was a proper subset of Y, then Y cannot be the null set. Because if X was a proper subset of Y, then if X had 0 elements, it can't be, and then what? So if X has 0 elements, then Y has to be bigger than the empty set. So Y cannot be the null set or cannot be the empty set because it has to have more elements than X. Okay, so now we're transitioning from these kind of theoretical abstract type questions to actually using sets to solve a word problem. So we're looking at a group of 150 students, and we know that 65 of them use Craigslist, 75 of them use eBay, and 25 don't use either. So the first thing we want to know is, are the sets in this problem well defined? So remember, a set is well defined if it's easy to tell, right? Our example of a set that wasn't well defined was the set of tall people, because how do you know if someone's tall, right? That's a subjective opinion. So for example, if we were going to go up to each of these 150 students and ask them, hey, do you use Craigslist? And hey, do you use eBay? Then they would give us a yes or no answer, and it would be really easy and simple and straightforward to put them in one of these sets. So yes, these sets are well defined. Okay, so now we want to know how many students know how to use both websites. So this is saying how many students use Craigslist and eBay. So remember that and with sets corresponds to intersection. So I think that the problem solving method that I would want to use is to draw a picture. That's just, I like to draw pictures to solve my problems. So that's what I'm gonna do here. So we're gonna make some letters for these sets. So U is always the universal set, and it has 150 students, just like the problem says, 150 students. We're gonna select C, denote Craigslist, which has 65 students. We're gonna let E denote eBay, which has 75 students, and we are not going to have a set denoted by neither, and you'll see why in just a second, because it's how we're going to draw this picture. So this picture, we're going to draw our universal set, right? Our universal set is always this box that our Venn diagram will live in. So we're going to have a circle for Craigslist and a circle for eBay. So we know that there are 150 students total. 150 students total. And we know that 65 are in Craigslist and 75 are in eBay. So I'm not going to put these numbers in the circle because I don't know where they go, right? I don't know how many of the 65 are here, and I don't know how many of the 65 are here in the middle. So I'm just going to leave those blank for now. But I do know that 20 of our students use neither of these services, and they are out here, right? So the 20 students who don't use Craigslist and also don't use eBay are out there. So we can use this information to see how many people are in the union of Craigslist and eBay, right? So we can find that 150 students from our total group of students minus 20 equals 130 students use Craigslist or eBay, right? Because we have 20 that don't use either. So that means we have 130 that use one or the other. So we have 130 students who are in, right, this union of C union E who use Craigslist or eBay, 130 students who are here. Okay, So now we can pick one of them. So let's say I want to know how many students use Craigslist. So I'm going to take the 130 that use Craigslist or eBay, and I'm going to subtract out the students that use eBay, right? I just want to focus on the students who use Craigslist, so I'm going to subtract that out, and I'm going to get 55 students who just use Craigslist, who are not part of the 75 who use eBay. So that means that those 55 students are right here. And because we know that Craigslist has to total to be 65, that means that right in here, we have to have 10 students. While I'm here, I'm going to rewrite these so that it's just a little more legible. This 65 and 75. So Craigslist has 65 total, eBay 75 total. Okay, and now because eBay has 75 total, and 10 of them are right there in the intersection, that means that we have 65 students that just use eBay, and that's all. So now we've identified exactly how many students are in every space in this diagram. So we have that 10 students know how to use both, because there are 10 students in the middle of our Venn diagram. Okay, so this is our first example of how we can use sets to solve these word problems that may be a little bit tricky if we didn't have this diagram to help us visualize. So that's the end of this page, and that is all for this video.